Fat has long been seen as an enemy in the fight for better health. But groundbreaking research suggests that it may actually hold the key to extending lifespan and enhancing physical performance. Scientists at Rutgers University have made a remarkable discovery. Brown fat, a special type of fat that burns energy rather than storing it, has the potential to significantly improve exercise capacity and promote healthy aging. Their findings suggest that activating brown fat in humans could revolutionize the way we approach longevity, and a drug designed to harness its benefits could be ready for testing within a year. Unlike traditional white fat, which primarily stores calories, brown fat is metabolically active, producing heat and increasing energy expenditure through a process known as thermogenesis. This tissue has long been associated with maintaining body temperature in newborns and hibernating animals. But recent studies indicate that it plays a much larger role in overall health. The Rutgers research team has now shown that enhancing brown fat activity in mice leads to a 30% boost in exercise performance and a 20% increase in lifespan. These remarkable benefits were even transferable when brown fat from the high-performing mice was transplanted into normal mice. The recipients saw rapid improvements in their physical abilities within just 3 days. What makes brown fat so unique is its high concentration of mitochondria, the cellular powerhouses responsible for producing energy. These mitochondria contain a protein called uncoupling protein 1, UCP1, which allows the cells to generate heat instead of storing excess calories. This process not only helps regulate body temperature, but also enhances metabolic efficiency and circulation. The Rutgers researchers found that brown fat actively increases blood flow to muscles during exercise, leading to better oxygen delivery, improved endurance, and greater physical output. It also stimulates the growth of new blood vessels, further optimizing the body's ability to sustain higher levels of activity. The long-lived mice in the study possessed unusually high levels of active brown fat, which appear to be the driving force behind their superior physical performance. The research team identified key biological pathways linked to these benefits, including the activation of SGRT3, a protein associated with longevity, and an increase in vascular endothelial growth factor, VEGF, which promotes blood vessel formation. These findings suggest that brown fat not only improves muscle function, but may also help prevent age-related decline in cardiovascular health. Perhaps most excitingly, the research points to real-world applications that could transform how we approach aging. Unlike many anti-aging interventions that require invasive procedures or extreme lifestyle changes, activating brown fat could be as simple as taking a pill. The Rutgers team is already working on developing a drug designed to stimulate brown fat activity, offering a potential breakthrough in preserving muscle function and metabolic health as people grow older. By boosting brown fat levels, individuals may be able to maintain a higher quality of life, remaining physically active and independent well into their later years. Beyond fitness and longevity, brown fat may hold the key to preventing a range of age-related diseases. Obesity, diabetes, cardiovascular disease, and even neurodegenerative conditions like Alzheimer's could all potentially be influenced by brown fat activity. Given its ability to enhance circulation, reduce inflammation, and improve mitochondrial function, this tissue may serve as a natural defense mechanism against the degenerative processes associated with aging. If the Rutgers team's findings translate successfully to humans, the implications for public health could be profound. One of the most intriguing aspects of the study is the way brown fat affects the aging process itself. The genetically modified mice that produced more brown fat not only lived longer, but also maintained a more youthful appearance. Unlike their normal counterparts, these mice showed fewer visible signs of aging, such as graying fur, hair loss, and muscle atrophy. This suggests that brown fat may play a protective role beyond just improving exercise capacity, potentially slowing down the overall aging process at a cellular level. While these discoveries are promising, researchers are approaching the development of brown fat-based treatments with careful optimism. The next step is to conduct clinical trials to determine whether the effects seen in mice can be replicated in humans. The Rutgers team is focusing on developing a therapy that specifically targets exercise performance and metabolic health, a strategy that could accelerate regulatory approval. If successful, such a treatment could not only benefit athletes and fitness enthusiasts, but also help aging individuals maintain their mobility and overall well-being. For those eager to take advantage of brown fat's benefits right away, there are already some natural ways to activate it. Cold exposure, such as taking ice baths or spending time in colder environments, has been shown to stimulate brown fat activity by triggering the release of norepinephrine, a hormone that activates UCP1. While these methods can provide short-term metabolic boosts, the long-term effects on aging are still being studied. Nonetheless, the possibility of developing a simple and effective way to harness brown fat's power through medication is an exciting prospect. The idea that fat, long considered an obstacle to health, could actually be a secret weapon for longevity represents a paradigm shift in the field of aging research. By unlocking the potential of brown fat, scientists may be on the verge of a major breakthrough in anti-aging medicine. With continued research and clinical testing, this discovery could lead to a future where people not only live longer, but also remain healthier and more active well into old age. The path from laboratory findings to real-world applications is always challenging. But with the growing understanding of brown fat's remarkable properties, the potential for transformation in human health has never been greater.